Howdy folks. In this video, I'm going to show you how to use a multimeter to fix this truck. Come on. We're going to start with the most basic piece, the battery. On this cab over, they're usually inside of this battery box, right? Everybody should know where the batteries are. We have a black terminal, usually it's black. Sometimes both terminals are black, but usually you have a black terminal and a red terminal. The black terminal is negative or ground, and you have a red terminal which is positive, or some people refer to as 12 volts. So if we want to check voltage at the battery, we're going to need a multimeter. So this is Ty's Fluke multimeter. You don't need to go out and get this model. This is a nice one, but your simple Harbor Freight one, the ones from Walmart, the EverStart ones. I had an EverStart one that I fixed a car on the side of the road with. Anything will work just for the basic checks that we're going to do today. There are more advanced meters like the one that I have that has a lot more features, but these are things that you don't need to waste your money on. This was like a $500 meter, but for fixing trucks, most people don't need this. So when you get your meter, you're going to have the meter and you're going to have the two leads. You're going to have a red lead and a black lead. So on these leads, you have two ends. You have a right angled end and a straight end. Either end will go into the meter. It does not matter which one that you use. It's sort of preference and kind of depends on what you're working on. Sometimes if you're working on something, you can use the right angled ones and kind of have it fit in your hand like this. Or most of the time I leave my lead like this and you can kind of poke around. On the meter, most meters you have ports at the bottom where the leads go into. They are color coded, so obviously the black one will go inside the black, or common is another word for ground or negative. So we're going to put the black lead there. We're going to hook up our red lead. Plug that into there. They just slide right in on this one, so there's no twisting or threading. And we're going to take our other side, and you can see on this meter we have an A for amperage or current, and then on the other side we have V for voltage. That's the ohm symbol. This symbol right here is for ohms. Some people say you can refer to it as resistance. I can't think of other things, but this also has this function here. This is the continuity test. So we're going to want to test voltage. We're going to put it into that slot. If we wanted to test current draw, that's a different video. We would put it on this side. But for our test right now, we're going to just measure battery voltage. So we're going to put it over here. And we have different options on the meter as far as what we want to choose. The sort of sine wave symbol, or the curve symbol, is for AC voltage. AC voltage is what you have in your house. Anything like 110, 120, 240, that's what you would use that for. You can also tell by hertz, which is the frequency of the wave. This other one, symbol with the dashes and the straight line, that is DC voltage, so we're going to turn it to there. The other ones, while we're at it, is millivolts. This is also for AC or DC millivolts. You would only really use this if you were measuring a very small voltage, something less than 1 volt. Typically you would use this if you were doing like a voltage draw. If you had left your truck overnight and it kept dying and you finally got your amp draw down to 1.2, you would start to use the millivolt function to find the last few tenths of a volt. Like we said, ohms is for resistance. B, I always call it the beat mode is what we kind of refer to it around here, but continuity. This diode test you're most likely never going to use, and then like we said, that's current. We've turned the dial to our DC voltage. We're going to place the black lead onto the black. Also on a battery, if they aren't labeled right, you should be able to find a spot in the dirt. Oh, here, you see that one has a negative symbol, and this side over here has a positive symbol. So even if they aren't color coded correctly, sometimes they use all black wire, sometimes they use all red wire. You can tell which lead is which based on where the battery is. So we're going to put our black lead onto the black terminal and our red lead onto the red terminal. And if he zooms in on there, I don't know if you can really see that. You might have to move the meter, Jordan. It says 12.73. Being this is a 12 volt battery and it was running, this is perfect battery voltage. Now you can kind of see a little bit of green on this connector here. So when we tell people to check battery voltage, this is a common spot for a lot of electrical issues, kind of cleaning up the terminals. You'll see green like that. Or if it's bad enough, you can put your lead on here, your 2 leads to measure battery voltage, and you will see if this terminal is really bad, you may see 9 volts, 10 volts. When you start to dip too low into the voltage, especially on these newer trucks, this is an older one, we'll have like a newer video or a different video on a newer truck at a different time, but this is just what we have. Low voltage is usually detected by the cab, but if it's not, some things can start to not work correctly or intermittently. So this one looks good. So if somebody says, you know, check voltage at the batteries, this is what you would need to do to start. We got a simple circuit wired up here. We just have 2 wires. This is very jank. Don't worry about it. Worst that can happen is the light bulb goes up. Very professional. Anyway, we have a simple circuit here where you have 12 volts or positive from the battery that goes into a light bulb, and then the negative that returns back to the battery. You have as what's known as a complete circuit. So what I just want to briefly touch on is open circuits and short circuits. So here we have a complete circuit. If something was to happen, we say a lot, oh, you might have a broken wire. That means that somewhere on a wire that you would have a bad connection, or maybe it gets pinched on the frame rail, zip tie is cut or something. It would basically be like doing this. Now we have broken the circuit, or we have an open circuit. If you had a short circuit, like on a sensor, like this is a differential pressure sensor off of a DPF. If you have what the ECM says is a short circuit, that means these 2 pins in there, I don't know if Jordan can go in there, there's 4 pins in here. If the ECM sees a short circuit on one of these pins, it would be like taking a wire or a screwdriver or something and tying them both together, right? So if we want to test this with the multimeter to see if we have an open circuit or a short circuit or complete, we are once again use the black lead on the common, and we're going to use the red lead on the voltage or the resistance or ohms and the continuity test. A lot of people like to simply go with the continuity test. You can use that or the resistance function. The continuity test is a little easier when you're by yourself. Like let's say we have a short circuit. It makes an audible beep. And if you see on the meter, it says 0 ohms. If this is on resistance, we short these together like this. You can see that we still have 0 ohms. So it gives the same reading whether it is on resistance or continuity. One is just audible, so if I'm over here and I'm let's put that to continuity. Let's say I was checking like a cab ground, right? And I can't look at the meter because I'm twisted up in here. And I have this sitting on the, thing. I can't see the meter. I can see that this cab is grounded without looking at the meter. If it was set to resistance, I would get the same reading. If you have a friend, maybe they could tell you what it reads, but in this case we don't. So we keep going with our resistance test here. If we have a light bulb that's not working, like let's say in the taillights or something, and we put where it's supposed to go, and let's say the ground. Oh geez, this is a little jank. We can see on our meter, this is another good point. that the meter does not complete any circuits. Like if you look at this right now, you see how this wire is broken? This is what a typical broken wire would look like. If I connect that broken wire back, the light comes on. The meter, even though it's set to continuity and you go like this, that completes the circuit in the meter, but when I do this, the meter does not complete circuits. So if I'm testing this, whether it's on continuity or resistance, I can see, and if you look up here, if I'm testing this, A does not complete the circuit, and B, you can tell that the OL on the meter down here, that reads, that's open circuit, right? That's where you could start with your diagnostics. Short circuits are kind of hard to show in demonstrations because they're usually, within a sensor or something, and we just throw shorted sensors out. But and I can't really short the battery because this would go up in smoke. So maybe we'll move on to some basic switch diagnostics. This is a basic switch. It has 3 pins in the back. And this is fun because I don't know what the pinout is. I don't know which connects to what, so we'll just have to figure that out here together. So if we just start by just maybe going end to end. Alright, we got nothing. Maybe double check that we're on beep mode. Okay, we are. So nothing there. Just go to the middle one. Nothing there. Alright, let's throw the switch one way. So this is a momentary switch, meaning when you hold it one way, it momentarily holds. Let's go the other way. So we'll try to test this. This is a bit tough. Nothing. Nothing. Does this switch even work? Alright. So we can see that this switch in this direction does connect. So when this switch is thrown this direction, it connects these 2 terminals together. So if we were to hook up our light bulb to the switch, so might have to cut for a second. So like we were talking about, I just real roughly hooked up this switch real quick just to show you when this switch is thrown, it connects those 2 terminals. It connects this wire and this wire to complete the circuit like we had, and that turns the light to the on position. So my wiring is terrible. Anyways, now if we want to check it the other way, we'll hook it up. So now that we're the other way, we can test the switch in the other direction, and the switch is good. Now if you know that this switch is supposed to work in the way that the switch thrown this way connects these 2, and the switch thrown the other way connects these 2, and you flip it one way and you don't see any continuity or the beep on one way, then you know that the switch is bad. You can look up, these switches have part numbers on them. Let me just take this off. This makes it easy to read. So they have part numbers on them. I doubt you can see this on camera. You can look up these switches online and see how the pinout works. We can talk about schematics in another video. But that is basically how a switch would work and how to test a switch. We're going to check cab grounds here, and typically what you want to do is you want to go from battery negative or ground to somewhere on the frame or the cab. I'm going to check it to the cab first. If you have yourself a little piece of sandpaper, it helps to clean up some of the grounds first. So if you get a reading like this where you put this on there and you don't see anything at first, I was like, oh, the ground is broken at the cab. Well, what you have to do is you kind of have to take the leads and kind of dig them in to get to the if there's any corrosion, you have to get past that, or any sort of rust or anything. So that's what I had this little piece of sandpaper for, but I'm just going to show you first. You have this on there, you can kind of dig the leads in, and you can see now we have a reading. But you also saw that it was a little erratic there. See how erratic it is? I think we have an issue with some of our reading point of that being great. So take a little sandpaper to it, clean off some of the rust. Now let's see if we get a better reading now. All right, there. So now we saw that we cleaned that up a little bit, that our measurement is actually accurate now. This does have a good ground from the battery negative to the frame. Now the other thing I wanted to show while I'm here is if I could get some assistance from the peanut gallery. Who's spying on us over here? All right. So does somebody want to open the door? So if we're watching, we have some resistance here. Need to clean this up better. Close the door. All right, open the door. If you see it go negative, that typically means that there is a current draw in the system. So go ahead and close the door. And you can see it goes back. So if you start to measure your cab ground or something and you have the door open, for instance, and there's a light on and you see negative on your resistance reading, don't take that as anything. If it reads negative, figure out where your current draw is and then go from there. We were starting to test the cab ground and we noticed that we're getting a lot of negative numbers, which means that there's some current draw which will throw off readings. So what we did is we went through and we removed all of the negatives from the batteries, and now we can get a true reading because there won't be any current draw. So JR has it on the cab up there, and I'm going to put it on the ground cable. I'll find a nice spot here. Dig it in like we talked about, and we have 0.08. So the cab ground on this is good. Like we checked the frame, and now we've shown where you're pointing on the cab there. You can test really anywhere in the cab, just somewhere that is metal. It's not going to work on plastic, fiberglass, pretty much anything that's not metal. So when you're doing this, you want to connect metal to metal to check the cab ground. What we typically want to see is things less than 10 ohms is usually what we like to see. If it's any more than 10 ohms, you can think about adding a ground strap maybe from the batteries to the frame and then the frame to the cab. I don't see the one on here actually, but that's what we would typically do if we were seeing low voltage inside the cab. There's this little bar at the bottom, right? This is sort of the analog replacement to watching the needle bounce. So when you would have an analog meter and you have, let's say, a voltage fluctuation or a turn signal, you could watch the needle go like this as the turn signal go off. You can see the same thing on this bar. I don't have a test that I can show, but maybe we can. So
just touch the leads together.
Yeah. You see how the bar moves? Or if there's something let me try to get a bad connection. Probably the better one would be voltage. Or something that is pulsing. Okay, you see how the bar is kind of in the middle there? You see how it moves around? So let's say you had a circuit that was flashing. But it's too fast for this meter to actually see the voltage changing, but you can see it on the that bar down there. You see that in the camera? Mm-hmm. So it's hard to say, oh, is that turn signal working? All I see is it just bouncing like that. Better meters, like the one that I have, has more resolution and you can see things faster, it reads the numbers faster. That's one reason to have a better meter, but sort of at-home diagnostics, not getting too much into the weeds, just, you don't need that. Another thing I thought of as far as a tip and trick, a lot of guys use meters to measure data links to see if the data link is working. So we'll have this in a future video. If you have a CAN bus system like you'll see in your diagnostic plug, it is a differential signal, so you'll have 2.5 volts and you'll have negative 2.5 volts. The difference between those is 5 volts. So somebody will use their meter, put it on ground, and then put it in the data port, and they'll see 2.5 volts. And they'll say, well, it has voltage there, the data link works. But if you actually use an oscilloscope, again, we'll get into that later, you can actually see that it's just a flat line of 2 volts, not a pulse signal. Because on a data link, there's a bunch of little pulses, not just one line, like, you know, a bit, another bit, another bit, another bit. That's too fast for this meter to read, especially a basic meter. If you have a Harbor Freight meter, it will never see it. It's way too slow. Some of the higher end meters, you could see it sort of bouncing on this gauge. You could see if maybe there's a data link there or not, but that's another thing. I can't think of any more tips or tricks. Do you think of anything?
Again, just the relay thing.
Yeah, tell them a story about the power box.
Okay, so I've seen this before. Guys add a power box or anything electrical, doesn't matter what it is, and it shuts off when they turn the headlights on, or when they roll the window down, it shuts off. I'm like, you grabbed a ground wire that you thought was a ground wire, but it was only a ground wire when it was connected to said relay. When the relay switches states, now it goes from ground to 12 volts, and it shuts off whatever you tied into it.
Yeah, so you have like, there's like switch power, which is like ignition key, you know, so when you hear us say switch power and unswitched power is the battery, there's no switch. Switch power is when there's 12 volts only when the switch is thrown. So it kind of is the same thing like he's talking about with like the ground. You can have like a switch ground that goes through a relay. So at one point, it's all connected when it goes to relay, but when this relay activates, it opens the ground. So that's why you could see your power box stop working.
Or another fun one that this happens a lot. Again, because relays switch from ground to 12 volts back and forth, and I've seen this happen a billion times where somebody fixed something in the wires, and like on your brake lights or tail lights or something like that, and all of a sudden everything starts doing weird stuff and blinking at the wrong speed and time and all that. That's relays flipping back and forth and not having the correct ground and the correct power supply, and again, things switching back and forth, and
right.
That's how you get all kinds of fun lighting problems.
But we'll go over that in maybe a part 2 or more of an intermediate video. But this is sort of just some basic electrical troubleshooting. Like I said, checking battery voltage, checking for corrosion on there to see if you're actually getting 12 volts like you should, checking cab grounds, checking frame grounds. That solves a lot of issues right there. So that's how you use a meter, and I guess that's it.
Go.
Howdy folks. Got electrical problems? In this video, I'm gonna show you how you
I'm gonna show you how you gonna fix it.
Howdy folks. Got electrical problems? Let me take you on. Alright, let's try that again.